Hello everyone. In this session, we are going to do some complex binary search interview questions, and this session is going to be really knowledgeable. So let's start. So we are going to do the modified binary search questions. So I have chosen some specific questions, lead code 153, lead code 33 and lead code 34. So we will start with lead code 153. So let me go to the lead code screen and let's read the question. So it's written that suppose an array of length n sorted in ascending order is rotated between 1 to n times. Sorted rotated array of unique elements return the minimum element of this array. So firstly, let's understand what do they mean by a rotated sorted. So let's understand what do they mean by rotated sorted array. For example, this is an array which is sorted in ascending order, that is 1, 2, 3, 4, 5. If I do a rotation to it, that means the last element, that is the max element, comes in the front, and all the elements are moved to by one. Similarly, if I do two rotations, then 4 and 5, the last two elements will be moved at the starting, and all these other elements will be moved by two steps. Similarly, in our example, we are being given this array 3, 4, 5, 1, 2. This has been rotated 3 times. So now the question is, find the minimum in the rotated sorted array. So we are given this rotated sorted array, we have to find the minimum element. If so we know that binary search can only be applied when the array is sorted. Now this array is sorted, but after being sorted, this is rotated. So can we apply binary search in this case? So let's see. We know that this array is partially sorted, that is some part of it is sorted, like this part 3, 4, 5 is sorted and 1 and 2 are sorted. So after 5, we see if we compare these two elements 5 and 1, we can see that 5 is the max element. After the max element, we have the first element, that is the lowest element. Had this not been rotated, then 1 would have been the first element. So we can use the binary search in this case. Now let's calculate the so what is the first step in binary search? We calculate the middle. So let's think about it and let's calculate the middle. The middle comes out to be 5, right? The middle element comes out to be 5 and the index comes out to be 2. Is the middle element greater than equal to the 0th element? That means, is 5 greater than or equal to 0? Yes, 5 is greater than 3. Then what we will do is we will move our left pointer. Left was at the 0th element. We'll move our left pointer to middle plus 1 because we want to find the smallest element, and we know that this array has been rotated. So there is one more case that we need to take care of. For example, if our array is rotated 5 times, so this is the array which is rotated 5 times. In this array, it becomes the original array. This array is same as the original array. So our first condition would be check if the 0th element, that is 1, is less than the last element. If that is true, then return the 0th element, because we know that this array has been rotated 5 times and it has transformed into the original array itself. Otherwise we will check if the middle element is greater than equal to 0 or not. If the middle element is greater than equal to 0, we have to search in the right part of the array, since we know that the left part does not contain the smallest element. So that makes sense, right? Otherwise, let's take an example. If the middle element is less than the 0th element, for example. So let us take this array 5, 6, 1, 2, 3, 4. This array has been rotated 2 times. Here the nums of middle is 2. So this is the middle element. Now let's check. So now let's check if 2 is greater than equal to the 0th element, that is 5. Is 2 greater than 5? No. Then move the right to mid. So we know that so we are here, we are on the second element. Our left is at 5 and our right is at 4, that is the last element. We will check if 2, the middle element, is greater than equal to 5 or not. So no, it is not greater than equal to 5. Then move our rightmost element to the middle, that is 2. That which means now the smallest or the minimum element will be in the left part of the array, because our middle element is less than our 0th element. So we'll move our middle to the we'll move our right to the middle element, because our the middle element could either be could be the middle element is the smallest element. So instead of moving the right to middle minus 1, we'll move it to middle. We have gone through the concept. Now let's write code for it. So, for example, this is our array 3, 4, 5, 1, 2. This has been rotated 3 times. We know that the left pointer will point to the 0th element, and our right pointer will point to the last element. Our first condition would be if nums of left is less than equal to less than nums of right. Is sorted, let's say for example 5 times, then it will become the original array. So we will check if the nums of left is less than equal to num of right, that is there is some rotations present in the array. If that is this condition is true, then return the left element, that is the 0th element, because we would know that in that case our first element is the smallest. Otherwise, do a binary search, and we know that to do the binary search, we have to calculate the middle. Middle is calculated as left plus right minus left divided by 2. This will give us our middle element, and then we will check if middle is greater than equal to the 0th element. If it is greater than equal to the 0th element, move the left to middle plus 1, otherwise move the right pointer to mid. This loop will work till left is less than equal to right. In the end, our smallest element will be pointed by the left pointer. So we will return the smallest element by nums of left. So let's do a dry run. So in the first iteration, our middle would be 0 plus 4 divided by 2, that is 2. So our nums of middle is 5, that is this element. Now we will check if 5 is greater than equal to nums of 0, that is 3. Yes, 5 is greater than equal to 3. Then move the left to the mid plus 1, because in that case our smallest element would lie in the right part of the array. So our left would become 3, and and we know that our right is 4. Now in the second iteration, calculate the middle. Middle is left plus right minus left divided by 2. So this is 3. So we will check if nums of 3, that is 1. 1 is greater than equal to 3. 1 is greater than equal to 3. No. Then move the right to mid. So our right is now 3. Now this condition, while left is less than equal to right, this condition will break, because 3 is less than 3 is condition false, and after that our nums of left would be returned, which is 1. That is nums of left is nums of 3, and the and the element at the third index is 1. So this would return our 1. So this is the code for returning the minimum element in a rotated sorted array. So let's try run it in the execute anonymous window. So I've copy pasted this code in the execute anonymous window, and let me, instead of return, I'll do a system.debug, because return does not work in the execute anonymous window. System.debug nums. Let's execute it, and the minimum element should be 1. Clicking on execute, debug only, and 1. Boom, the element is 1. And if I remove this, so and now our minimum element should be 2. So let me click on execute, and our minimum element is true. So boom. So we have solved Leetcode 153, find minimum in the rotated sorted array. Now the next question. The next question is search in a rotated sorted array. So we are given the rotated array we have already discussed earlier. Now instead of finding the smallest element, that is the minimum element, we have to find the target. So we have to find the target, and in this rotated sorted array. So target is at the 4th index, 0, 1, 2, 3, 4. So target is at the 4th index. So let me go to my VS Code and see what we will do. So let's think about it. So our, let's say our nums array is this 4 5 1 2 3. So let's think about it, and so this is our nums array. Now we have already, in the previous question, we have already found the smallest element in the rotated sorted array. So we already know a way to find the smallest element in the rotated sorted array. So if I give this input to this code, if I give this input to this code, the above code is returning the smallest element, right? Now I can change it. Instead of returning the element, I can do something like this: return the index. So if I return the index, I would from where the smallest index is present, right? So the above code for this input will return the index as 2 because 0 1 2. So at the second index we have the smallest element present. Now so we know that after we have found the minimum in elements index, that is 2, we can divide array into two part. The left part is 4 and 5 and the right part is 1 2 3. Both are sorted. Now our binary condition says that it requires a sorted array. So can we do two binary search on first time on the left part of the array and second time on the right part of the array, and we give it the target as 10. So what we will do is, firstly we will find the smallest element index. So we are calling the smallest element index as the pivot element. So we'll calculate the pivot element from the above code. So this is the class which I'll show you. I've created a class in Apex, and I've called that function as find minimum in a rotated sorted array. Once we find the minimum index, we will divide it into two parts. We will divide the array in two parts. So this condition, so let's talk about this condition. If our pivot index is 0, that is our minimum element is at the 0th index. That means our input is 1 2 3 4 5. So our minimum element is at the 0th index. That means we have to only do one search, give it a full array, and do the search for target. Otherwise we have to do two searches, one in the left part and one in the right part. Left part is sorted and the right part is sorted. So how we will determine? So we know that for the above array, for 4 5 1 2 3, we will return the pivot index as 2 because at index 2 1 is present. So we will give the index as 2 and end of the array, that is the array dot size, and the other one as 0th element, that is the first index, to pivot index minus 1. So pivot index is 2 and pivot index minus 1 is 1. So the left part would be 4 and 5 and the right part would be 1 2 3. So based on the index we can do two searches on the left and the right part, and in the end we will find the element. So let me copy this and let me go to the execute anonymous window and let's run it to see if this is actually working on this window. So I've copy pasted the code that was in VS Code. So we have to find the target 2 in the rotated sorted array. So let's run it and see if it's works. So I'll click debug only, and it is saying that element found at index 3. So at 0 1 2 3. So at third index we have target as 2. Let me search for 5 and see if 5 exists in the array. So found element at the first index. So this is the index it found. Now let us see the implementation of these two functions, find minimum in sorted array and do binary search. So this is our class, and if I open the do binary search functions, so this is what we learned in our last class. So this is the simple binary search implementation. So we'll have the left and the right element, we'll find the middle of left and right, then we will check if middle is equal to target, then return the middle. Otherwise array of middle is greater than target, then right is equals to middle minus 1, otherwise left is equals to middle plus 1, and if the element is not found, then return minus 1. And the complexity is big O of log n, right? Yes. So now let us see the implementation of find minimum in a rotated sorted array. So this is what we did in our previous question. That was find minimum in a rotated sorted array, turning here the index instead of the actual element. So it is the same thing that we have discussed previously. Successfully solved Leetcode 33. Now let us solve Leetcode 34. It is also an interesting question. So it says that find first and the last position of an element in a sorted array. So this is our sorted array. So here we are only taking the sorted array. There is no relation of this with the rotated array. So rotated was different, and this is just like a normal sorted array. But the issue here is we have repetitive elements here. So 7 is repeating twice and 8 is repeating twice. Now it is saying that in an array there would be multiple elements that would repeat twice. Now we have to find the first occurrence of target and the last occurrence of target. That based on the concepts which we have learned previously, let's see how we can solve it. So this is our search implementation class. I have created one function that is binary search multiple elements. So here I have one parameter that is true or false. So we will have to do two binary searches, one to find the first index and one to find the last index. If I pass this parameter as true, I am searching for the leftmost element. So, and if I pass it as false, I am searching for the rightmost element. I'm passing this array 5, 7, 7, 8, 8, 10, and I want the target as 8. So this is the nums, this is the target, and this is the boolean value. In the end, I'm returning a list of two elements, that is first index and the last index. So let us go to binary search implementation class and see this function. So this is calculating the first element, we are calculating the last element, then we have a loop while first is less than equal to last, then we are calculating the middle element. Now then we are checking if nums of mid is equal to target. Then we will update this found index element. This will tell us what was the last index our element was found, since the target could be occurring multiple times. So found index will tell us the last occurrence of the target. Then we will check will this parameter which we were passing it from the execute anonymous window is left. We will check if is left is true, then last is equals to mid minus 1, because we want to search in the left part of the array. We want to see if there is if 8 is getting repeated in the left multiple times or not. So to find the leftmost element, right? So we will move our last pointer would be at the end of the array. We'll move it to left minus 1. Now our binary search will be performed in this portion of the array. So we will search for the target, and if the target is found, again we will move the left to target minus 1. Now we will search in this part of the array, and similarly we won't be finding any occurrence of 8. So our found index would have the leftmost occurrence. Hope you understood it, because the other part is the same. If the target is greater than nums of mid, move the first to mid plus 1, otherwise move the last to mid minus 1. So if you don't understand this part, go to my previous video and understand the binary search algorithm in depth. So otherwise, if the is left is false, we will be moving the first to mid plus 1. So let's say our middle is here, middle is this element, that is the third element. Now our is left is false because we want to find occurrence of 8. To search for the last occurrence of 8, we have to search in the right part of the array. To search in the right, we have to move the first to mid plus 1, because first is at the starting element. So we'll move it to mid plus 1 so that search can only happen in the right part of the array. Hope you understood this code. Now what I'll do is I'll copy paste this and we will see if this is working or not. I'll go to the execute anonymous window, I'll paste this and I'll click on execute. Debug only. Boom, the answer is 3 and 4. So now we have successfully solved Leetcode 34 as well. So in this video, we have solved Leetcode 153, Leetcode 33 and Leetcode 34. Hope this was a knowledgeable session for you guys, and hope you like this video, and do subscribe to the channel for more such videos in the future. Thanks everyone.